Hello students, welcome back to module 5. So this part of the module is module 5 part 6. Here today we will discuss about the one more type of non-preemptive scheduling. We already discussed about non-preemptive scheduling types, that is first come first serve basis. The second one was last come first serve basis, right? Now today we will discuss about the priority based non preemptive scheduling. In priority based scheduling, a priority which is unique is associated with each task. Okay, the priority of a task is expressed in different ways, like a priority number, the time required to complete the execution, etc. Okay, so here we were in the second point. Uh, okay, here the priority is assigned. Okay, when there are multiple processes to be executed, they are held in a queue, right? So now we are discussing about how these multiple processes are executed by the, or in which order these processes are executed by the processor or central processing unit. So in this category we have priority based scheduling. Different priorities are assigned. Okay, so the priority can be a just number, okay, or the priority can be in the form of the time required to complete the execution. In any way the priority can be assigned. Okay, in number based priority assignment, the priority is a number ranging from 0 to the maximum priority supported by the operating system. The maximum level of priority is operating system dependent. Okay, Windows CE supports 256 levels of priority, ranging from number 0 to 255 priority numbers, with 0 being the highest priority, then the 255 will be the least priority. The priority is assigned to the task on creating it. It can be also be changed dynamically during the runtime if the operating system supports this feature. Okay, so priority is assigned while creating the task itself, and it can be changed dynamically if the operating system supports this dynamic priority changing feature. Okay, the non-preemptive priority based scheduler sorts the ready queue based on the priority and picks the process with the highest level of priority for execution. Okay, so in case of non-preemptive scheduling, the scheduler sorts the ready queue based on the priority assigned to each processes. Okay, so with the highest priority comes first for the execution. Here is one example for non-preemptive scheduling, priority based. Okay, uh, three processes. Let me use the pointer. Three processes with process IDs P1, P2, P3 with estimated completion time 10, 5 and 7 milliseconds and priorities 0, 3, 2. Okay, where 0 being the highest priority and 3 being the lowest priority respectively enters the ready queue together. Okay, three processes with process IDs P1, P2, P3 with the estimated completion time of 10, 5 and 7 milliseconds. Okay, with the priorities assigned as 0, 3, 2. Here 0 is the highest priority, 3 is the lowest priority, enters the ready queue together. Calculate the waiting time and turnaround time TAT for each process and the average waiting time and turnaround time, assuming there is no IO waiting for the processes. Okay, in priority based scheduling algorithm. So now we have to calculate the average turnaround time and average waiting time, assuming that there is no IO waiting. So processes need not wait for the IO input output devices for execution. They can be readily executed. They are mainly CPU oriented. The scheduler sorts the ready queue based on the priority and schedules the process with the highest priority, okay, coming first, and next the Next, lower priority. Okay, the highest priority should come first, and okay, in the descending order they are scheduled in the descending order of their priority. Okay, so the highest priority task should come first, and the second task will be the next highest priority, and then it will go on in the descending orders of their priority. So now we know that P1 has 0 priority, that is the highest priority, then 3 is the lowest priority, then 2 will be having the priority which is intermediate between, right, uh, 0 and 3. So how the non-preemptive scheduler will schedule these processes? Okay, the process with the highest priority is P1. Next, the process with the next highest priority will be P3, right? And the process with the least priority will be P2, right? So 0, 2, 3, their corresponding processes are P1, P3 and P2. So we know here the order in which the processes are scheduled for execution are represented as P1, okay, which is having the highest priority, and next P3, right, having the next highest priority, and then P2, the process having the least priority, right? P2 has the priority 3. Okay, now they are scheduled for the execution, and these are their execution times, and these are the waiting times for each of the processes. Okay, so about that we'll discuss in the next slide. Okay, so first we will calculate the waiting time for all the processes. Okay, the waiting time for all the processes is given as, we'll start with the first process. Waiting time for process P1 is equal to 0 millisecond. Okay, because P1 enters the ready queue without any delay, right? So processor takes it for the execution without any delay. So 0 millisecond is a waiting time for P1. P1 is the first process which is executed by the processor. Waiting time for P3 will be 10 millisecond because P3 is executed only after completion of P1, and the execution time of P1 is 10 millisecond. So this 10 millisecond will become waiting time for P3. Waiting time for P2 is 17 milliseconds, right? So P2 is the third process in the ready queue. So here, before P2 being executed, there are two processes whose execution has to be completed. So the sum of execution time of P1 and P3 will be the waiting time for process P2. So then the waiting time for process P2 will be 10 plus 7, that is 17. Now, average waiting time is the waiting time for all the individual processes divided by the number of processes. Okay, the sum of waiting time for P1, P2, P3 divided by the number of processes is 3, and the answer will be 9 milliseconds. Then we will calculate the turnaround time for each process. Turnaround time definition goes like this. The turnaround time is equal to time spent in ready queue plus the execution time. So the turnaround time for process P1 is 10 milliseconds. Okay, that is because the time spent in ready queue is 0, execution time is 10 milliseconds. So the sum will be 10 milliseconds. Then the turnaround time for process P3 is 17 milliseconds because the time spent in ready queue for this will be 10 millisecond. 10 millisecond is the time spent in the ready queue by the process P3, right? And then the execution time of P3, that is 7. So 10 plus 7, 17. Turnaround time for process P2 will be 22 millisecond. In this case, the time spent in ready queue will be 10 plus 7, right? Plus the execution time of process P2 will be 5. So 10 plus 7 is 17 plus the execution time of P2 5 millisecond. So totally this will be 22 millisecond. Then the average turnaround time is turnaround time for all the processes, that is 10 plus 17 plus 22 millisecond, divided by the number of processes, that is 3, and the result is 16.33 millisecond. Okay, so I hope there is no confusion in calculating the turnaround time. So be careful, turnaround time is a sum of time spent in the ready queue. Time spent in the ready queue is nothing but the waiting time plus the execution time of the same process. Okay, so time spent in the ready queue for the first process is 0 plus the execution time of it is 10. Time spent in the ready queue for the process P3 is 10 and the execution time of P3 is 7. So 10 plus 7. Time spent in the ready queue for the process P2 will be 10 plus 7, 17 plus the execution time of P2 is 5. So 17 plus 5 will be 22 millisecond. And the average of turnaround times of all the three processes, that will be 16.33 millisecond. So drawbacks of priority based scheduling in case of non-preemptive scheduling algorithm. Okay, the non-preemptive priority based algorithm possesses the drawback of starvation, where a process whose priority is low may not get a chance to execute if more and more processes with higher priority enter the ready queue before the process with lower priority starts its execution. So what happens here is, okay, if the processes having higher priority keeps on entering the ready queue, then the processes having lower priority will not get any chance for the execution. So this is a drawback, and this is called as starvation. The processes having lower priorities will face the situation of starvation. They will not get the CPU time or CPU resource for the utilization, for the execution. Sorry, not for the utilization, for the execution. They will not get chance for execution. Okay, and that is called as starvation. Starvation can be effectively tackled in priority based non preemptive scheduling by dynamically raising the priority of the low priority task or process which is under starvation. So, the meaning of starvation means waiting in the ready queue for a longer time for getting the CPU time. Okay. So, how we can tackle this problem of starvation? That is by changing the by dynamically changing the priority of the low priority process, okay, which is under starvation. Even though the priority is low, the priority is changed so that the low priority process gets the chance for the execution by the central processing unit. Okay, so this is called as dynamic priority, uh, dynamic changing of raising of the priority. The technique of gradually raising the priority of process which are waiting in the ready queue as time progresses for preventing starvation is known as aging. Okay, so this process of dynamically changing the priority is called as aging. So we discussed about three topics here. First one is a drawback, that is because if the high priority processes keeps on entering the ready queue, the process which is already in the ready queue but having the low priority will not get CPU time for the execution. Okay, and this process is called as starvation. Okay, this is a problem where the low priority processes will not get CPU time, okay, which results in starvation. Starvation means waiting in the ready queue for a longer time for getting the CPU time. Okay, and this problem can be uh, addressed by dynamically raising the priority of low priority task. Okay, so dynamically means even though the process is having the low priority, the priority can be raised to higher priority during the execution or the during the runtime. Okay, and that is called as dynamic raising of the priority of low priority task, and the name for this particular process is called as aging, the technique of gradually raising the priority of process which are waiting in ready queue as the time progresses for preventing starvation is known as aging. Okay, understood, right? This particular process of raising the priority of a low priority process during the execution which are facing the problem of starvation is known as aging.